Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be talking about naming hydrates. So what are hydrates? Hydrates are just compounds that contain water in their crystal structure. So hydrates are normally ionic compounds. We still name ionic compounds the same way we've been naming them. We still write the formulas for them the same way we've been writing them. The only difference is that these compounds contain water inside of them, and the number of water molecules can be important. So how do we name the hydrate part, the water part? All you do is you name the compound normally, and you add the appropriate Greek or Latin prefix to it. So I'll give you an example. This blue crystal is called copper 2 sulfate, which again, you could write the formula for, pentahydrate. And so if you think back to our Greek and Latin prefixes, penta means 5. So that means that there are 5 water molecules trapped inside of each little formula unit of this crystal. These you've definitely seen before. They're Epsom salts. Epsom salts are hydrates, actually. And again, depending on how hydrated they are, you have different numbers of water molecules in their crystal structure. So the way that we're going to kind of do this is we're going to kind of use the molecule prefixes that we had to represent the hydrated part. So just like you heard me say pentahydrate, you could have monohydrate if there was 1, or dihydrate if there was 2, or trihydrate if there was 3. So that's the only difference, is adding the word hydrate at the end and then telling us how many water molecules there are inside of it. And so since I said this was copper 2 sulfate pentahydrate, I figured somebody would at least probably want to know what that looks like. So this is what it would look like in its actual structural form, right? We've got a copper 2 ion, we've got sulfate ions, and then we have these 4 water molecules surrounding the copper 2 ion, and we have 1 water molecule surrounding this sulfate ion. And so these are the 5 water molecules, the 5 in the pentahydrate part of this. All right, now just a reminder, here are all of them. Now let's actually go through and name these. So I have CaCl2. So we know Ca is calcium, we know Cl is chloride, and then I have to now add this hydrate part. So I have 2, that's di, so this would be dihydrate. So calcium chloride, dihydrate. Next, FePO4. Okay, Fe is a transition metal, right? So we have to remember our transition metal Roman numerals here. What is phosphate, PO4? That's a 3-. I don't have any subscripts, so that must mean this is a +3. So I have iron 3 phosphate. And then how do I say 4? Tetra. So that's tetrahydrate. Next one, also transition metal, CoCl2. Co is cobalt, Cl is chloride, but I need to know what my charge is. On this one, at least it's a little easier. I have this right here. I have this little subscript which tells me this must have been a +2. So that's cobalt 2 chloride. And then 6, that's hexahydrate. Last one, I've got sodium, I've got carbonate. So that's easy, that's just sodium carbonate. And then 10 is deca, so that would be decahydrate. But see how, again, this is just naming ionic compounds, and then we're kind of just adding in the hydrate part at the end to let you know how many there are. If you're wondering about this little multiplication sign that you see, that is how you write the formulas for them. So you don't just say, calcium chloride in the formula, you have to tell me how many water molecules there are. So we do a little multiplication sign. This is like a product sign you might see in math. And then you have 2 water molecules, or you do multiplied by 4 water molecules, or multiply by 6, or multiply by 10, or any one of these other prefixes. So that's how you would actually write them. Let's see if we can do the reverse though. The reverse sometimes is a little bit harder. So magnesium sulfate heptahydrate. Most people would say, okay, great, I know hepta, that's 7. So heptahydrate, I know I have 7 water molecules at the end. So it's just, can you remember how to name ionic compounds? What's magnesium? Mg, it's a 2+. Sulfate, SO4, that's a 2-, so they cancel. So it's just MgSO4, and I'm multiplying by heptahydrate, 7 water molecules. Next, I've got sodium acetate. So if you don't remember, sodium, Na+, acetate, C2H3O2-. And then trihydrate means I have 3 water molecules. So it would look something like this. Next up, barium hydroxide. Barium is a 2+, Hydroxide is OH minus. So think about this. If I'm moving my 2 from my barium all the way down to the hydroxide, I'm going to need to make sure that I put this in parentheses. Octahydrate, that's 8. So it would be BaOH2 times 8 water molecules like that. This last one's probably the hardest one. So ammonium and oxalate are both polyatomic ions. Ammonium is NH4+. Oxalate we never really see. It's C2O4 2-. So again, I'm going to be moving a 2 from here to here. Monohydrate means 1. And so I would end up with something that looks like this. NH42, C2O4 times H2O. And notice, just like in mono, like carbon monoxide or something, it's understood to be 1. You don't have to put a 1 down. All right, so hopefully that clarified some things. If you have any questions, let me know.